Okay, still on the theory of odd numbers. We have done a lot, right? Now, factors. We want to look at factors. What is factors? How do we find factors of numbers? This is very important in mathematics. This is very, very, very important. So please take it very, very serious. To find the factors, we have to see the number that can divide the bigger number without any remainder. That number is called a factor. This is a layman definition. Okay, now let's look at example to make it clear. Okay, now this is the question. Find all factors of 72. 72 is divider. The number we are thinking of that can divide this number without remainder is called divisor. The result we get out when we divide this guy by this guy is called quotient. And the result we get is called factors. Now let's start. 72 is the number. Let's start from the first number, 1. Can 1 divide this guy without remainder? Yes. 72. 72 by 1 is what? 72. No remainder, which means 1 can divide 72. So 1 is a factor. Take it again. 2. 72. Let's use 2. Can 2 goes here without remainder? Let's check it. 72 divided by 2. This goes here. We have 3. We have 6. 36. Do we have any point? No remainder. Since there's no remainder, 2 is a factor of 72. 3. 73 divided by 3. Can this go? 72 by 3. How many times 3 goes in 7? It's 2. What remains is 1. In 12, 6. So it means 4. So 3 in 12 is 4, which means 3 is also a factor. 3 is also a factor. Let's try 4. Can 4 goes? Let's check. 72 by 4. 4 goes, if 2 can goes, is at the 6. So 2 again, 18. That is 18. That's a smart way of solving. Since we have 2 already, and 2 goes in 4, so use the result and equal 2. Okay? You have to think smart. Don't work hard, but work smart. You get it? So, which means 4 is also a factor. What about 5? 5. 72 by 5. Is it possible? No. We are going to have a remainder. 72 by 5. 7, 5 goes here, 1. Remaining 2. 5 in 22. That is 4. Remaining something, right? So which means 5 cannot work. 5 is not a factor. Let's try 6. Can 6 goes? If 2 and 3 can go, 6 will go. Interesting. 6 will go. Let's check it. Seven 2 by 6. Divided, when we divide 2, we have 36 by 3. And then 3 goes here now is what? 12. So which means 6 is also a factor. 7. Obviously, 7 cannot go, right? 7 cannot go. Since we know 7 cannot go, because it will be 10, something. So it's not possible. 8. Can 8 go? Two and 4 goes. So 8 should go. Let's check it. So if you use 2 first, you have is 6. If you use 2 again, 2 again, 2 here, 2 here, 2 again, 9. So, which means 8 goes in 72. Now we can list out all the numbers. The number that divide and the result we get, they are all factors. They are all factors. So to write them out, let's write them here. 1 is a factor, 2 is a factor, 3 is a factor, 4 is it? 5, no, 6, yes, 7, no, 8, yes, 9, yes, because if this one can give us result, this can also give us result. 9, yes, 12 is a factor, 18 is a factor, 24 is a factor, 36 is a factor, and it's, of course, 72 is a factor. So these are the factor of 72. Interesting. Solve more problem. The more you solve problem, the more you understand mathematics. Mathematics is not for lazy people. Yes, you must be ready to solve. You don't read mathematics like this. 1 plus 1 is 2. No, you have to solve problems. Okay, good. So we are still in the spirit of theory of whole numbers. Don't forget, we have done counting, even numbers, odd numbers, multiple numbers, and we have just concluded factors. Now I want to look at prime whole numbers. What is prime number? Name and definition. Prime numbers are numbers that can only be divisible by 1 and itself. Meaning, prime numbers are factor of 1 and itself. Now, let's look at some example. Which of the whole numbers, 12, 13, 21, 27, are prime numbers? So we have to check using our previous knowledge, factors. Don't forget, prime numbers are numbers that can only be divided by 1 and itself. So, 12. What are the factors of 1, of 12? 1 can go. Let me write it like this. 1 can go, right? 2 can go, unfortunately. 3 can go, 4 can go, 6 can go, and 12 itself. So this is not a prime number. This is not a prime number because you can see that the list of the factors are many. Second one, factor of 13. 1 can go, obviously. Anything can be very wrong. 1 can go, can 2 go? No, 3, no, 4, no, 5, no, 6, no, 7, no, 8, no, 10, no, 11, 12, no. 13, yes. So, 13, 1 and 13, the only number that can divide this guy. When I say divide, it means without remainder. So, please keep notes of that. Without remainder. So, which means 1 and 13 is the factors of 13. So which means 13 is a prime number. 13 is a prime. Okay, 21. 21. Can 1 go? Yes, obviously. 2, no. 3, yes. How do I know? Okay. 2 plus 1 is what? 3. And 3 can go. So remember the divisibility. Yeah. Mathematics is very interesting. Foundation is very important. And that's why we start from the foundation. So 3. Yes. 4. No. 5. No. 6. No. 7. Yes. Because if you divide 3 by 21 is 7. So 7 is a factor. 8, no. 9, no. 10, no. 11, no. 12, no. 13. So, which means the factors of 21 are this guy. So, since the factor is more than 1 and itself, it means it is not that 21, it is not a prime. The last in the example, 37. Obviously, 37, 1 can go, yes. 2 cannot go, because to find the 2, for the divisibility, you have to be 0. The last number must be 0, 2, 4, 6, 8. What of them is here? 3 cannot go, because 3 plus 7 is 10, and 3 cannot go to 10. So 3 is not possible. 4. The last 2 digits must be divided by 4, which is 5. The last number must be 5 or 0. So you see, it's not concerned with our divisibility. So this is very important so that you can understand this. So which means no number except 1 and 37. So which means 37 is a prime. So I give yes. The next on the list is composite O numbers. What is composite O number? Look, let me tell you. A number, or I say the whole number or numeral that are not prime, it is composite. Finish. Once it's not prime, it's composite. So the two numbers we did before, 12 and 21, they are not prime number. It's what? Composite. Okay, let's test a sample. Let's test a number. Let's say the question says, is 1179 a prime number or composite number? To check whether this guy is a prime number or composite number. Don't forget, prime number, a number that can only be divided by itself and 1. And composite number is the opposite of prime. Good, now let's check. 1 is a factor. Yes, we know. Can 2 go? 2 cannot go. Why? Because for 2 to go, the last number must be either is 0, 2, 4, 6, or 8. So 2, it is out. 3, can 3 goes? We have to do what? Sum each of the digit number. 1 plus 1 plus 7 plus 9. This gives us 2, 9, 18. Can 3 go in 18? Yes. Which means this guy, it has 3 as one of its factors. It's not a prime number. So you don't need to check anything again. You don't need to check. Once one disobey, you conclude that it is not a prime number. That is what? A composite number. So which means 1179 is a composite O number, or is a composite. So now let us work on prime factors. Prime factorization. First, what is prime? Number divided by itself and 1. Factors, we list them, right? Number that can divide a big round number without any remainder, right? Now, what to put them together? Prime factor. Mathematics is very interesting. It's very interesting. Now, let's look at this example. Express 224 as a product of a prime factor. We have a lot of methods, but I will teach you only 2. Let us use tree diagram. That is, factor means number that can divide this number without remainder. So the last number that we get, it is now become prime, right? That is, nothing can divide it again. Yeah, it has reached its destination, right? Good. Now let's start. Let me use the first method. 24. So start with 2, the first number. Of course, we know that 1 can go, that one for sure. So 2. And 2 goes here? Yes. 2 goes in 2 is 1. 2 goes in 4 is 2. No remainder. If there is a remainder, then this is a factor. So take it. 2 can go again, right? 2 goes in 12 is 6. No remainder. Can 2 go again? 2 can go. 3. Can 2 go again? No. So 3. 1. So it has reached the prime. Nothing goes again, right? So we can say 24, the prime factor of 24 is 2 times 2 times 2 times 10. Right? If you multiply it, you must get this back. Another method, if you don't like this one, you can use 3 method. 24. You can split it into 2, right? If you want. So here I can say, what can give me this product is 4 and 6. Because 6 times 4 is 24. Do you agree? Yes. So this one is not a prime number, yes? Because something can still go inside here. So it's not a prime number yet. So you can still divide it. So you divide this guy, you can say 2 is multiplying 2 can give us 4. Right? Is 6 a prime number? No. So which means something can still go. So what can go? 2 can go. And give us 3, right? So you can say 2 and 3. So which means, can anything go here again? Nothing can go. Only 1 and itself. Only 1 and itself. Only 1 and itself. Only 1 and itself. So it has reached the last destination. It's 2, 2, 2, 3. That is 2 times 2 times 2 times 3. If you like this, the way I break it, you can also break it this way. It's your choice. What is important that we come at the same, we arrive at the same place. If I want to go to the market, if you like, I can use my leg to go to the market. If I like, I can use my motorcycle. If I like, I can use bike. If I like, I can use tricycle. I can use car. Even if I have African magic, I can disappear and reappear. So I can divide this guy. 24, I can say 8 can give me 24. And 8 times 3 is 24, right? So I can break it in this 2. It's my choice. Now, 3, it has reached its prime. We cannot divide it again. But 8, we can still divide it. You can say 4 times 2 will give us 8, right? This has finished, but this one you can still divide it, right? That is 2 times 2, which means 2, 2, 2. So anyone you like, you will surely get the same result. That's why I love mathematics, you know? The only thing is what is important is make sure you are doing the right thing. So if you do like it this way, if you like it this way, if you like it this way, we arrive at the same destination. Okay. So quickly, of course, if you stop here, there's no problem. But you can do something more mature by introduce what you call exponents of whole number. Exponent. Exponent means something carrying something. Okay? If I carry something on my head, it's called exponent. That is, if I have 2 to the power of 4, it means that 2 in 4 places. 2 times 2 times 2 times 2. This is exponent. If that is, you multiply this in 4 places. If I say 3 to the power of 2, it means 3 in 2 places. 3 in 2 places. So which means this will give me what? This is 4, 8, 16. 16. And this one will give me 9, right? So I can have as many exponents as I want. And also, since I can write this in form of this, I can also write this guy in form of this. And that takes us to this place. So instead of going to write 2 times 2 times 2 times 2 times 3, I can say it is 2 to the power of 3 times 2. You see? It's more, it's shorter, right? So I have introduced exponent. exponential. Some people call it index. Some people call it indices. You know, you have some names, different names sometimes for some the same thing. Why? Just like yourself. Maybe your name, your first name is John Polo. Second name is Mohammed. And your last name is Isaac Newton, for example. So it is you that is bearing the same name, right? But you do not change, it's still you. Exactly. So I can call it exponent, I can call it index. And some of us will be saying that, why am I studying this? Why am I studying this? I'm just using. Look, all these things have applications in all the field. Is there science, the social sciences, businesses, everywhere. For example, index, the theory, prime factor, is a good example is cryptography. Cryptography, where you use coding, you code in computer, right? So this is a very good application of this method. And of course, the last part we are going to look at is this is very important. This leads to all what we are going to be doing in mathematics. We are going to be using this word LCM, HCF, lowest common factor, and highest common factor. This is multiple. This is very important. So let's solve one or two examples on this, and that will be the end of prime number.